Okay, so have a nice day, everybody. This will be the PERT analysis or the program evaluation. What I mean is the program evaluation and review technique chart that we'll begin to discuss is what we have discussed in the previous video that is dealing with the category of pertains to the definition as well as the steps. But right now, I'll begin to illustrate how we could be able to do the sequential process of this one up until you could be able to get the probability of this. Now, by calculating first, since the expected time that you'll begin to deal with this is actually first thing first that you have to do with this one in order for you to achieve the expected time, you have to get the 4M so that it will be basic for you actually. Now for the 4M, since this is our O optimistic time and this is our most likely time and this is our pessimistic time. For this category actually class, what we're going to definitely calculate the the 4M in order for us to calculate the expected time. In our expected time as we have deal and our expected time that is the O plus 4M then plus the P over 6. That's how you will deal with that formula. We'll be going to deal with that one basically how we could be able to go ahead and work on that process later on as we go through the process. So we'll be going to do it step by step. So let's start then for the 4M already. This will be the implementation. So let me just grab a calculator first in my Mac. So where's the calculator? So for this one, since you will begin to calculate the 4M, then 4M is definitely that is 4 times 6, then 4 times 4, then 4 times 8, then 4 times 9, 4 times 4, 4 times 5, and 4 times 3, 4 times 2. So that equates to 4 times 6. So that is 24. 4 times 4 is 16. 4 times 8 is let me just that is 32, I think. Yeah. Then 4 times 9 is 36. 4 times 4 is 16. 4 times 5 is 20. 4 times 3 is 12. And 4 times 2 is 8. So this is the 4M right now that we were able to calculate. And we will be going to get the expected time, which will be that formula. So in that formula, since we're able to have the 4M already, so it will be basic for us to identify already. So in this process, we'll just go ahead and calculate 4 plus 6. Oh, no. 4 plus 24 plus P, because this is your P and this is your O and this is your 4M divided by 6. So this is the process. So we'll begin to deal with that in a step-by-step manner because we cannot be going to go ahead and do the process if you were not able to do it step by step. Okay, so 4 plus 24 plus 10, that is definitely 38 divided by 6. So you have to divide this 38 into 6 and that will equate to 6.33 since it is actually 2 decimal points. And right now, the O here is 3, the 4M right now is 16, the P is 12 divided by 6, and then that will equate to 3 plus 16 plus 12 plus, I don't know, that is a 31 divided by 6 is equals to 31 divided 6 is 5.16. And afterwards, your O right now is 5 plus your 4M is 32. Your P is 14 divided by 6. That is definitely 5 plus 32 plus 14 is equals to 51. and divided by 6 is definitely 8.5. That's how you will deal with this. And for this one right now, your O is 6 plus your 4M is 36 plus P is 13 over 6. 6 plus 36 plus 13 is definitely 55. 55 divided by 6 is definitely 9.16. So this here then is O is 2 plus 4M is 16 plus P is 19 divided by 6 is equals to 2 plus 16 plus 19 is equals to 37 divided by 6. So 37 divided by 6, that is that will equates to 6.16. And then afterwards, your O is definitely 8 plus your 4M is 20 and plus 18 divided by 6. And that will automatic 8 plus 20 plus 18, and that will equate to 46. 46 divided by 6, that will be 7.67. Then afterwards, your O right now is 9 plus 4M is 12 plus 15 is divided by into 6 is equals to 9 plus 12 plus 15. That will automatically be 36 divided by 6. This is 36. I'm so sorry. Let me just redo. 36 divided by 6. It will be automatically 6. Now, right now here is your O is 7 plus your 4M is 8 plus your P is 16 divided by 6. Automatic 7 plus 8 plus 16 will definitely be 31. 31 divided by 6 is automatic 5.17. So for this one class, this will be the expected time that we're able to calculate that here. Then, since in this category, you will begin to draw the you will begin to initial calculate the expected time. Right now, since we're able to calculate the expected time, you will also calculate the expected variation. This is expected time. Expected time. And you will have to calculate as well the expected variance of each activity. Expected variance. The expected variance is actually calculating the variance is the theta of squared, which will be the P minus O over 6. That is 6 squared. So that's how you will calculate that here. Then an expected variance, which will be your P in here is definitely 10. 10 minus your O is 4 divided by 6. So 10 minus 4 is definitely 6 divided 6. That is actually squared. So 6 divided 6, that is 1. So 1 squared is 1 times 1 is equals to 1. And here then your P is 12 minus your O is 3 over 6. So squared, and 12 minus 3, that is 9 over 6 squared is equals to 9 over 6, 0.5 squared. 0.5 times 0.5, that is 0.25. So your calculation here then will be 0.25 for this category here. Now afterwards, we're able to identify already, and your P in this kind of For B to D is 14. 14 minus O. Your O is definitely 5 divided by 6 squared is equals to 14 minus 5. That will become 9. 9 over 6 over squared. So 9 over 6 is still the same thing. 1.5. I'm so sorry. Let me correct everything because I actually made a wrong answer here. This is actually a 1.5. So 1.5 times 1.5 is definitely 2.25. So the same thing here, it's 1.5 squared is definitely 2.25. So that is your sorry, 2. Then afterwards, P 13 minus 6 over 6 squared. 13 minus 6 is definitely 7. 7 divided by 6 is something. 7 divided 6 is 1.16, 17. So 1.17 squared times 1.17 is 1.37. Next will be, we're done with here, 19 minus 2 over 6 divide 2. Squared. 19 minus 2 equals 17. I'm sorry that went out. I don't know what happened to my thing here. So let me just go ahead and reopen that so that we could be able to finish the process. So after this one, you will begin to let me just so 19 minus 2 is 17. Over 6. So 17 divides 6. So that is 2.83 squared. 2.83 times 2.83, that is 8.0001. Now, afterwards, by the way, this is somewhat connected here then because let me just put here. Okay. Just a second. Let me just put a label for that one so that you will not be going to have any confusion. Okay, so afterwards is it that is 8 and minus 8 over 6, that will become square here. So 8 and minus 8, that is 10 divided 6 squared. 10 divided 6 is that is 1.67 squared. 1.67 times 1.67 is equals to 2.79. So here then in the D to F, you have to here then that is 15 minus 9 over 6 squared, and then equals 15 minus 9 That is basically 15 minus 9. Yeah, that is 6. Over 6 squared. And then 1 squared is equals to 1. So afterwards, it will be here equals 16 minus 7 over 6 squared. So it will become 16 minus 7 is definitely 9 over 6 squared. So 9 over 6 is 1.5 squared. So 1.5 squared is definitely 2.25. So this is the process that you will begin to get for the expected variance. After the expected variance, you will begin to calculate the expected duration. Compute the standard deviation of each activity. When we say standard deviation, that is for the standard deviation class. When we say standard deviation, that is the theta. No. That is the theta equals to P minus O over 6. There's no squared at all. So what will happen? It is indeed 10 minus 4 over 6. Then it will become 6 divided 6. It will become 1. That's how you will do it. Then 12 minus 3 over 6 is equals to 9 over 6 equals 1.5. Then afterwards, 14 minus 5 over 6. No. There's no square at all. It will become 9 over 6 as well. It will become 1.5. And then 13 minus 6 over 6 is equals to 7 over 6. And then the answer will be 1.17. Then here then 19 minus 2 over 6 will become 17 minus 6 divide 6, and that will equate to 2.83. So it will become 18 minus 8 divided by 6 is equal to 10 divided 6 and equals to 1.67. Here then 15 minus 9 over 6, that will become 6 over 6 equals 1. And here then 16 minus 7 over 6 equals 9 over 6 equals 1.5. So this will be the calculations that you will be going to deal with here. After you calculate the standard deviation, since that is the chart that we are having right now, you don't forget that you will be going to draw the critical path at the chart already. For the you can draw it right now. So A to B, we'll draw that one through the vertex as well, like a tree or a graph. I'm so sorry with the noise because there's a lot of background noise here in my area. So I'll just make sure that everything will be done as accordingly. Hopefully that you could really understand the background noise since it's something a lot of people see. Now A to B, then A to C, then B to D, B to D, and then B to E. So calculating here, then C to E will be connected here then as well. Then D to E will be here, and D to F is connected as well. So that means to say, and E to F. Now, according to that one, you will be going to label this into the expected time that you do have. The expected time that you do have earlier is definitely you will be going to identify, because in our identifying the critical path, it must be the E over your E is equals to the L accordingly. So we'll begin to deal with that later on. So let me just go ahead and the A to B, the expected time of A to B is definitely 6.33. 6.33. Then 5.16 to A to C. 5.16. Then B to D is 8.5. Then B to E is 9.16. Then C to E is 6.16. And then D to F is no, D to E is 7.67. Then D to F is 6. And your E to F is 5.17. So for this one right now, see, this is the chart of our PERT, and we will begin to identify right now the critical path, which is your E. This is your E, and your must be equals to the L. Your E is the maximum, and your L is the minimum. And they must be equal, and that will be the critical path that we'll be going to choose later on. So here then, our thing that we'll be going to calculate here then is the E first. So from A is that is set to 0. That is your E right now is equals to 0. So we will begin to our E is actually from the node of A up until the F. So here then, by calculating that one, 0 plus 6.33, that is your A here. So 6.33. Now, afterwards, connected to C as well, it will become 5.16. And afterwards, your D is, since you were able to have 6.33 in your B, then B is connected to E. So 9 plus 9.16. So your E right now here is, there's a lot of E, which is for B to E, that is 15.49. Then there is also C to E, which is 5.16 plus 6.16. That is 11.32. But there is a D to E. We'll need to get first what is D. So 6.33 in B plus 8.5 is 14.83. That is your D right now, because you will add the E of B to the B to D vertex. Now, that is 14.83. Since E is 14.8, D is 14.83, you have to add that into the 7.67, which is connected into the E. So that will become 22.5. So since our E is the maximum, so what is the maximum between the three? That is 22.5. So we can choose 22.5. Now, in this category right now, we'll be going to deal with the F. This is the F right now is your from E is 22.5 plus 5.17. That is 27. So 27.67. And there is from D to F as well, 14.83 plus 6, it will become 20.83. Now, what is the E? Will become 27.67 as your maximum right now. So we're able to identify the E already. So we're done with that. So what will be our goal right now? We'll begin to also calculate the L. So since E is from the initial state, which is an A, our L is from the goal state, which is the F. Now F is the value of F right now. That is automatic as 27.67. So E and L is already equal. So we can choose that path later on. Now, you will be going to deduct this 27 into the the ancestor, or predecessor, the predecessor of this. What is the predecessor of F? There is D. So 27.67, you will deduct that into the 6 goes to D. So 21, your L right now here is, so there will be two L's here actually. So L is 21.67, and we'll be going to calculate F to E. So your F is 27.67 minus 5.17. That will be 22 point, your L right now is 22.5. That means to say they are equal, so we can choose that path later on. Then afterwards, calculating this one here, 22.5, for that 22.5, you have to deduct that into the previous path, which is goes to D, 7.67. That is 14.83. So therefore, our L here, we can choose 14.83. So 14.83, and this one is equal, so we can choose that path later on. So 14.83 is the L here. We can also check here the L for the B, but we can check first the C. So the C will be 22.5 from E, 0.5 minus the 6.16, that is 16.34. That means to say they are, we cannot choose that path because they are not equal. Now, E to B, we can calculate 22.5 minus 9.16. 9.16 is 13 point, so 13.34. And afterwards, yeah, you have from D as well, which is D is 14.83 minus 8.5. So it will become 6.33. So therefore, your L that we can choose is 6.33, because we will be going to choose the minimum for the L, not the unlike E. Unlike the E that we're getting the maximum, but for the L, we're getting the minimum actually. So the minimum for this one right now is definitely the L here is the 6.33. I'm so sorry. Let me change the color because it will be misleading actually. Let me just change that for a moment. I'm so sorry. Stand corrected. Let me just change it first. Okay. Okay, your L right now that you can choose is 6.33. That means to say we can choose that path later on. Now, your L for C to A as well, 16.34 for L minus the path 5.16 goes to A is 11.18, and there is also a 6.33 minus 6.33, so that will become a 0. So what we can choose, L is equals to 0, therefore they are equal. So that is, we can now identify the critical path. How to find the critical path? The critical path is E is to L. So therefore, the critical path here is those are the path that having the E is equals to L. So that is A to B, then B goes to D, D goes to E, then E goes to F. Why? Because A here is E and L is equals to 0, and E here right now and L is equals to 0. Equals to each other, and D to E is also, B to D is also having here the equals to each other, and E right now here as well is equals to each other for E, and goes to F is equals to each other. So that's how you will identify the critical path. So therefore, you do have the critical path. And if you will be going to calculate the critical path, A to B, the value is 6.33. Then B to D, you have to calculate that one, 8.5. So, D to E, for D to E, that is 7.67. Then E to F, that is 5.17. Now, calculating this one, since we're done with that, 6.33 plus 8.5 plus 7.67 plus 5.17 is equals to 27.67. So therefore, this is your that is equals to your chart right there. By the way, the our basis for this PERT chart is our project is 30 days 30 days basis. So we will be going to get the probability if this activity A to EF, if it's likely, what will be the percentage or what will be the probability of getting this to success within 30 days. Now, we're done with that. So we can calculate right now the we're done with the calculation of that one. Let me go ahead and proceed to the next step, which you have to also get the expected. Let me just review. I wasn't able to have it in here. I forgot. So, what you will need to calculate as well is the expected project duration along the critical path. So the expected project duration okay, the expected project duration for this. So let me reiterate, class, this is the expected project duration already. Expected project duration. The expected project duration is 27.67 days. That was stated right there. Now we will also calculate the expected variance of our critical path. So in calculating the expected variance of our critical path is definitely calculating the variance. What is the variance of A to B? What is the variance of B to D? And what is the variance of D to E? And what is the variance of E to F? Now, what is the variance that we do have here? A to B is 1. B to D is 2.25. And D to E is 2.79. And E to F is 1. So that's how you will identify. Then total that. So your expected variance is 1 plus 2.25 plus 2.79 plus 1. So that is your expected variance of critical path is 7.04. Now, after calculating the variance, you have to get the expected standard deviation. Expected standard deviation of, I'm so sorry, my PC was just turned off. Okay, just give me a second because this my PC just went off. This is not working. Okay, just a moment. Maybe my PC was really tired. Let me just end
Ako driver gitu no ako pagbuhat ko. Eh bata naman kay ko. Para na gitu.
So the expected standard deviation of the critical path
Kaya ba? Paano ko na? Sabi, Dinoy bilang lagi, apas na